Hi, welcome back to another Blazor build. This build was meant to be a simple follow-on to my earlier video, creating an accessible tooltip, as I had originally thought that I would just build a tooltip that was opened by a button instead of opening on focus or hover, basically a copy and paste of the tooltip code with the addition of a button. But that rapidly changed when I started looking at it a bit more closely. This process was not straightforward either, as there is no solid definition of what a toggletip is or any specific ARIA authoring patterns or roles for a toggletip. Most of the generic statements that I came across were along the lines of a toggletip is something that pops up to display more information, a bit like a tooltip, but in response to an explicit user action as opposed to being automatically displayed on mouse over or when the triggering element received the focus. The rationale behind toggletips and their usage is that tooltips are a little too exclusive with regards to accessibility, with toggletips being more inclusive. How do users of touchscreen devices see a tooltip attached to a button without a mouse or a keyboard to hover over or set focus on the tooltip trigger? And if they touch a button, the underlying action may complete before they get to see the associated tooltip, and that's assuming that they see it at all. Users of voice activated software face other challenges, such as if the tooltip trigger does not have a visible accessible name, then how do they activate it? More on that when we look at the build, as pretty much all the toggle tips that I came across had no labels, only icons. I guess that's why a couple of them also had tooltips. To be honest, the simplest answer to most web accessibility issues is to just put clear, legible text on screen. But for those designs that will not allow for that, carry on watching. The first question that I needed to answer was whether or not a toggletip was just something that displayed plain text like a tooltip, or should it allow for structured markup. To answer that question, I went back to the post by Steve Falconer, written in 2016, the person I believe credited for the term toggletip. In that post, Steve mentions that a toggletip may be used for those times when paragraphs of text, structured text, and interactive content is to be displayed, continuing on to say that a toggletip does not display content on mouse hover. I then spent some time looking at applicable ARIA authoring patterns in order to try and build something that followed some sort of best practice. I eventually settled on the disclosure pattern, which best aligned with Steve's notion of a toggletip. I also knew that I would want the toggletip to be dismissed when the user tabbed out of the toggletip, as it was not a modal dialog with a focus trap, and that the user should be able to dismiss it with a key, such as the escape key, as well as to have a close button after the content, so screen reader users would know when they were at the end of the content. Mouse users could also use the buttons, or just click on something outside of the toggletip to dismiss it. The next problem to solve was that of focus. Where does it go when you open a toggletip? And if the toggletip includes scrollable content without any interactive elements, how do keyboard users scroll that content? As a side note, many browser vendors now make scrollable containers focusable as default for the issue described, but oddly, at the time I made this video, Google's Chrome does not. Because of this, I knew I may have to add a tab index on the toggletip container that holds the user supplied content, i.e. the render fragment. I say may, as I did not want to add a tab index if it was not needed, as unnecessary tab stops can be annoying for keyboard users. I also knew from experience that sadly in Blazor there is no way that I could dismiss the toggletip if the user clicked outside of it. As such, I knew I would have to add a bit of JavaScript, and as I was needing JavaScript, I thought I may as well inspect the user supplied markup and add a tab index to the toggletip content area if it needed a scroll bar. This issue of closing things with Blazor components has got to the point where I should just make a little NuGet package with a few little common JavaScript functions linked to a service to negate having to use JavaScript for these types of things, so stay tuned. Okay, I got a little sidetracked. Back to the issue of focus. Where do you put it on opening a Toggletip? Given that I had decided on using the disclosure pattern, with its content not requiring immediate attention or capturing input, I felt it best just to leave the focus on the trigger so the user could decide how to navigate the content or immediately close it if it was opened by mistake. I was now ready to start building what is currently on screen, hidden behind the little square speech bubble icons. Let's see it in action before going through the code. Before I turn on the screen reader, given how it takes over your arrow keys, I will first show the second toggle tip about toggle tips without the screen reader. Its content exceeds its bounds, so the toggle tip content area will show a vertical scroll bar along with the addition of a tab index for keyboard users. I will tab 2 and press the enter key to open the toggle tip. Tab to the scrollable area and scroll with the arrow keys before tabbing to the close button to close the toggle tip. The content had no interactive elements, but I was able to tab 2 and scroll to view it all. The close button is outside of the content area that needed to be scrolled. When I closed the toggle tip, as mentioned, the focus was set back to the toggle tip button, i.e. the little icon. It should be noted, despite the erroneous text on the page saying no label for the last toggle tip, that for the demo I gave all the toggle tips a label. However, the display of the label is optional, set via a component parameter. With regards to the last toggle tip, buried in the lorem ipsum text, just so you could see the alignment, I positioned its label to the left with its text starting with 2 lowercase t's placed next to a word ending in t. The toggle tip button uses the ARIA label attribute for its accessible name. Both this attribute and the on-screen label are populated from the same component parameter, so the visible text is the accessible name, irrespective of whether or not the label is displayed. For me, the most difficult aspect of this build was the CSS, as trying to get the vertical alignment of any label text to match its surrounding text while keeping the toggle tip button and its icon looking pretty central was challenging to say the least. I would estimate that this one aspect took 75% of the total build time. Whilst I am talking about the CSS, something that I do not normally use is the M unit, as I find it too confusing trying to remember what it's relative to for its size, as opposed to just using rems, which are relative to the root. But for this build I used M's for the toggle tip icon button, label and close button, so if you just drop the component in the middle of some text, it will size to match. I did not add any font sizes to my demo render fragment contents, so they too will just be sized accordingly. We will see that in a minute when I click the toggle font size button. On screen there is also information about the sizing of the toggle tips. For this component you can choose small, medium or large to set the maximum size that the toggle tip can grow to. The toggle tip has a fixed minimum size of 350 pixels by 100 pixels, meaning it will never get smaller than this size, with the maximum width and height measurements based on the percentage of the viewport width and heights. I was in two minds about using a single enum with predefined sizes as opposed to using two parameters, one for the maximum width, the other for the height, so there was more control, but eventually settled on using the enum. The underlying process is the same, the enum just uses predefined variable values, that's all. For those who viewed the Tooltip build, this time I have not added any JavaScript to check that the bounds of the toggle tip are within the screen boundaries. If I add this, I will update the GitHub repository. You can always view the TypeScript code created for the tooltip for ideas if you need this. Let's turn on the free screen reader NVDA and listen to what it sees. I will tab to the first toggle tip, press enter to open it, and then press the down arrow key to have NVDA read the content. I will then press the down arrow key again instead of using the tab key, and NVDA will then read and position its virtual cursor on the close button, so you will not see any change in its state. After which I will then just press the enter key to close the toggle tip.
About emails button collapsed. Expanded. Email toggle tip that looks like a tooltip. Button close about emails. About emails button collapsed.
NVDA first announced about emails button collapsed. I pressed enter and it announced expanded. I then pressed the down arrow key and it read the toggle tip content. I pressed the down arrow key again and it announced button close about emails. Pressing the enter key again closed the toggle tip, with NVDA announcing about emails button collapsed. I will now tab to the about toggle tips button, use the space key to open it, tab twice to get to the close button, and then press enter.
Email address. About toggle tips button collapsed. Expanded. About Toggletip's head. Close toggle tips button. About toggle tips button collapsed.
The familiar announcements were made. I will now tab to the keyboard information toggle tip, use the enter key to open it, and then press the down arrow key so it starts reading, but immediately press the escape key to close the toggle tip.
Toggletip's left toggletip, label right, keyboard information button collapsed. Expanded. Heading level 3 specific keys used for the toggletip collapsed.
The screen reader just announced collapsed on closing the toggle tip as the focus was still on the button. I will now tab to the last toggle tip, open it, and tab to the close button so the focus is on that, and then press the escape key.
Toggle font size of the lower image, some text between 1 and 2 and 3. TT Blazor R meaning button collapsed. Expanded. Close Blazor R meaning button. TT Blazor R meaning button collapsed.
This time the screen reader announced Placer at button collapsed. I will tab back to the toggle font size button, press it a couple of times, and then navigate back to the toggle tip.
Toggle font size of the lower image, some text between 1 and 2 and 3 IEM button. Font size changed to 2 IEM. Font size changed to 3 IEM. TT Blazor R meaning button collapsed. Expanded. Close Blazor R meaning button. TT Blazor R meaning button collapsed. Toggle font size of the lower image, some text between 1 and 2 and 3 IEM button. Font size changed to 1 IEM.
I will open a toggle tip and minimize the screen so you can see how the toggle tips respond without being repositioned, although probably not a typical user action. Well, that's it for the demo. Let's see the code, starting with a component on the home page. On line 21, we can see the first component with its assigned parameter values, with the text assigned to the ARIA open and close labels, which were part of the announcements made by the screen reader when we landed on the open and close buttons. The render fragment named content, as seen, holds any structured markup. Now let's go through the project structure, folders and files, ending with the toggle tips markup and code. I used the Blazor web app template, selecting interactive server with the location of global. I then added a Razor class library project named blazorbuilds.components to the solution and added the appropriate references. I take this approach so you can see how all of the pieces fit together if you go this route of having separate projects for one or more components. In the app.razor file, I added the content path for the component style sheet, which I just named main. Not shown, but I also added using statements for any components or code references to the imports Razor file in both projects. That's it for the server project. In the components project, I added my usual assets folder to the web root folder with subfolders named CSS and JS for the style sheet and JavaScript module that the TypeScript code will output. I added a project folder named assets with a subfolder scripts for the Toggletip TypeScript file and an SCSS folder for the Sassy CSS files. Let's review the TypeScript file. On line 1, we just declare a weak map to store references to event handlers used so we can remove them correctly when the Blazor component gets disposed. On line 2, we create a simple arrow function that just invokes a method in our Blazor component. It does not pass any parameters to Blazor, it just calls the Blazor method, which is enough for our needs, as this call lets us know when the focus has left our component. The add tab index if scrollable content does what its name suggests. It checks the bounds of the toggle tip, and if a scroll bar is required, adds a tab index of 0 to the content element. This is done in case the user's browser has not implemented the keyboard focusable scroller feature, like many have now done. This function is called each time the toggle tip is opened, as we use viewport widths and heights and the screen size may have changed. Line 15 is our register lost focus handler function, where our component provides all the necessary information in order to create a handler attached to the focus out event that will call back our Blazor component method focus left control, the name of which is in the variable callback name. The Blazor callback ref is the .NET object reference object that is used by JavaScript to invoke our component's named method. Before adding the handler, I like to check that it's not already registered, after which we register it for the focus out event and add it to our weak map with the content element as its key. Last is our unregister focus handler function. Given the container element, our map's key, we try and get the handler, removing the event listener, finally removing the weak map entry. At the end of the file, we use the export statement to declare which functions can be imported for use. Next, we look at our Sassy CSS files within the SCSS folder. The root Sassy CSS partial file contains global CSS variables used by our Toggletip. I have used global variables as opposed to just defining these within the Toggletip's partial file, as these are from a common set of variables that I use for all of my components. By using the same set of variables, I can change one value which is then reflected in all of my components that use that variable. In other words, it allows me to theme my components in a very simple way. The SVG icons partial file just contains classes and the SVG data for the icons used by the Toggletip. The closed tooltip icon is the one I use for the tooltip build. Next, the Toggletip partial file that contains all of the CSS for our component. The more I use CSS, the more I seem to create. I use the B.E.M block element modifier naming convention, with elements being denoted by the double underscore. The main Toggletip class is the block part of B.E.M. For those not familiar with Sassy CSS, the ampersand is not the same as native CSS nesting. The ampersand just denotes the parent selector appending the text after it to create a new CSS selector. For example, ampersand double underscore open dash wrapper, when output, becomes a class selector with the name of Toggletip double underscore open dash wrapper. There is quite a bit of CSS, so I will not be explaining how it all works, and frankly, without seeing the Flexbox vertical alignment algorithm, it would be difficult, as the vertical alignment caused me some real grief on this build. Logically, looking at the class selectors, we have the Toggletip class, our container. Importantly, this uses displaying line. Originally I used inline flex, but I could not get it to do what I wanted it to. Before we continue, picture the component in your mind. It's an icon button that can have a label to the left or to the right of it, and this component can be placed in the middle of any text. We need the label text to be on the same line as the surrounding text, so all of it matches perfectly. and we need the icon button to look correct vertically. The display in line allows us to put the component on the same line as the text, the first part of the puzzle. To make this discussion a little easier, I have added a multi-line comment below the CSS with the HTML structure and class names. As we are using inline, the label should now be on the same line, matching its surrounding text. The Open Wrapper class contains our button that has the Opener class, which in turn contains the icon used. If you have built icon buttons, you know that you can get things nicely aligned just by using Flexbox, and that is what I did to get the icon horizontally and vertically aligned inside the button. Okay, but we need the button to be vertically in line with the text so it looks like it belongs there. Here is the problem. The icon to look okay may need to be sized independently from the text, i.e. you may have 1 rem for the text, but in order to see the icon given its design you might need 1.5 rem. However, having a bigger icon size means the button's height gets bigger, which in turn increases the line height of the text. So what we need is to somehow get a nice sized icon vertically aligned with the button and its surrounding text, but without increasing the line height. This is where the Open Wrapper class helps, which is defined as inline flex. As it's in line, it should sit on the same line as the labels, the second part of the puzzle. We can use this as an anchor and set the Opener button to use position absolute relative to the Open Wrapper, taking it out of the normal flow. In plain English, we can set heights and widths on the Open Wrapper so it's perfectly in line with everything, and then move our button with the icon which is above everything so it looks correct without affecting line heights of the surrounding text. Job done. This provides another benefit and solves an issue that has plagued me for some time. For accessibility, the smallest target size for a button is 24 by 24 pixels, and depending on your line height it may fit, but what happens if you need a larger target size? You can get the code and play with this yourself. The button's background is transparent with the icon in the middle of it, with the focus outline going around the button. Change the min target size from 24 to 44 pixels and watch what happens. Spoiler alert, nothing, everything looks the same. However, you now have a big button with a target size of 44 as indicated by the focus ring. I will now expand the selectors and comment on anything of any significance. The content area uses a 2-row grid, as we want one row to hold the user supplied markup and another for our close button. This is so the close button is always visible, as the content could be scrollable. I put the button at the end to indicate to screen reader users that they are at the end of the content, so they can use the button to return to the opener or just leave the toggle tip and go to the next item on the page appearing after the opener. The &# indicates a modifying class in B.E.M, and these classes modify the position of the toggle tip relative to the button, with the pseudo elements responsible for the little triangular tips. I explain how all of this is done in my Tooltip video, so I would suggest you watch that one for more information. All of these position modifying classes are pretty much the same. The content class is simple. It just puts itself in the first row of the grid, allowing its vertical scroll bar to become visible if needed. It can only grow as big as defined by its parent, the content area. The footer class just sets some bounds for the close button using the flexbox to align the bottom vertically, but also to shove it to the right hand side. Finally, we have the closer class, used by the close button, that houses a span with its icon. The last Sassy CSS file is the main file. This is not a partial file as indicated by the lack of leading underscore in its name. This file just includes the partial files that should be part of the final output to the main CSS file that is output to the CSS folder within the web root. For those who have not used Sassy CSS, a CSS preprocessor, I made a short 4-minute video about the Visual Studio extension that I use and how to get started using it. I use the same settings in all of my videos, so it's easy to follow along. Next in our project is the common folder with 2 subfolders, extensions and seeds. Within the extensions folder I have a small static class for helper extensions regarding if-then statements. Bizarre, I know, but I like neat one-liners where possible. Only one method needed for this component, but I have quite a few others, and I still have not gotten around to putting them all in their own little NuGet package. Another job on my to-do list. Within the seeds folder we have an enums file that contains 4 enums used by our component, all of which are self-explanatory other than the style as enum. This is something I now use in all of my components for theming. The global value file just contains constants used by the component. I think all of it is pretty self-explanatory. The only things of interest are the last 4 constants. The ones ending with the var name are the named CSS variables for the max width and height CSS properties, with the values used defined by the subsequent 4 constants. You can change these values to use whatever unit and size that you prefer. The last couple of constants and the static method are for my theming scheme. Next is the Toggletip folder containing our Toggletip component. Yet again I have chosen to use a single razor file as there wasn't enough code in it to make me want to split it. I used to always split them when I first started working with Blazor, but for smaller components like this I don't mind the single file approach. The markup structure was somewhat explained when we looked at the CSS, so I will only cover the important parts. Although collapsed, the comments would explain that originally I used inline flex and as such had one span for the label text which used the order property to put it left or to the right of the button, but that was problematic, so now I just include one or none of 2 labels based on the component's label position parameter. The @ref directives appearing on lines 4 and 22 capture the element references for these divs, so we can just pass them directly to the JavaScript. This saves passing IDs and then doing a lookup to get the ID within the TypeScript. The @ref directive on line 15 for the button is so we can set focus to the button from within our code. The button uses the ARIA label attribute populated by the ARIA open label parameter, which forms the button's accessible name. As described within the ARIA authoring disclosure pattern, we also set the ARIA controls attribute with the value of the control that the button toggles, the content area, line 20. The button also uses the ARIA expanded attribute, which signals the state of the content that it controls, expanded or collapsed. As the icon is not needed for screen readers, we just use the ARIA hidden attribute to hide it. Our content area on line 20 has the tab index of -1, which may seem odd, but this is needed. This was almost a stumbling block. We need to dismiss the toggle tip when the user clicks outside of it, but equally we need the toggle tip to remain when the user clicks on it. The TypeScript code uses a statement that basically says if the item clicked is not in our Toggletip container, then inform our Blazor code that it can be closed. However, this mechanism needs a focusable area to work correctly. Adding a tab index of -1 makes this a focusable area. Without this, if you clicked on the open Toggletip, it would just disappear because JavaScript has no idea that it's a focusable region within our component. Line 23 is where the render fragment containing the markup will be output. On line 26 is our close button. Again, we use the ARIA label for its accessible name and use the ARIA hidden attribute to hide the icon from screen readers. Some may wonder about the accessibility of the close button for users of voice-activated software, and that's a good point. My rationale for the close button was to indicate to screen reader users that they were at the end of the content. Users of voice-activated software can just say the name of the button that expands and collapses the toggle tip, for example, about emails, the first toggle tip in the demo. These users can also say a command such as numbers to have the software overlay any interactive controls with numbered labels, which the user can then use as commands, such as click number 1. Although it is possible for such users to use unlabeled controls in the manner just described, it is an additional step for them to make, which otherwise they would not need to do if all controls were labelled with the accessible name. I also made the display of the label optional to keep things flexible, as not everybody has accessibility requirements. I have made plenty of applications, both desktop and web, over the last 20 years that have had zero accessibility requirements. I think that about covers it for the markup. Last but not least, the C# code. The first two component parameters use the editor required attribute to warn the user if they forget to add these values. The parameters down to line 50 are self-explanatory, and if not supplied, uses the defaults specified. The 3 element references have already been mentioned. Line 56 holds the .NET object reference that we will pass to JavaScript so it can call a method within our component. Line 57 is to hold a reference to our JavaScript module output by our TypeScript code. Line 59 holds a unique ID to be used to link the ARIA controls attribute to what it controls. The next 2 booleans are used to show and hide the toggle tip. Originally, I only used the show content boolean for both the ARIA expanded attribute and to get the appropriate class for the toggle tip, but ran into problems with what the screen reader would announce when setting focus back to the button. You can read the comments in the source code currently collapsed for more information. The onParametersSet method is the first of 2 Blazor lifecycle events that we use. This method is called when the parameter values have been assigned. There is another method called setParametersAsync, which can be used to check the values before they are assigned to the parameters, but I tend to use this one. Within this method, I just raise an exception if the user did not take notice of the editor required design time warnings, as we do need these values. The toggle content method is called when the icon button is clicked or the user pressed the enter or space key to show or hide the toggle tip. When showing the toggle tip, we need to check if it's scrollable, and if so, add a tab index. However, in order for JavaScript to get the dimensions, we need to remove the content area hidden class that uses display none. For this to work, we will then need Blazor to render and update the DOM before calling JavaScript. The task.yield returns control in order for Blazor to do this before continuing. I have placed a link to the Microsoft documentation regarding the rendering process within the collapsed comment. The handle key down method is for when the user presses the escape key to close the toggle tip. Again, for different reasons, we need to yield control to cause a render before closing the toggle tip via the handle click to close method. The handle click to close method is called from both the onClick event and from the handle key down method, and it causes the toggle tip to close, setting focus back to the icon button. If the ARIA expanded field is true, we will need to set it to false, having the DOM updated before setting the focus back on the icon button. The onAfterRenderAsync method is the second of the Blazor lifecycle methods that we use. And all we do within this method is on the first render, now that the DOM is available for Blazor server applications, call the register.js callback method to set up our callback method with JavaScript. Within the register.js callback method, we get a reference to our JavaScript module and then call the register method that we created in TypeScript, passing it all the necessary parameters, the .NET object reference for the callback mechanism, the name of the method for JavaScript to call, a reference to our Toggletip div for use with the focus out handler, and a reference to the content div for checking and adding a tab index if it's scrollable. Next is the check add tab index method that just delegates this to the JavaScript function that we exported. On line 125 is the get content area classes method, which is called from the markup and just returns it the appropriate classes based on the method parameter values. The get size style method returns CSS variable values for use within the markup's inline style, which will update the underlying CSS values. It's a powerful technique if you have not seen this done before. The return is nullable, as we can get Blazor to exclude an attribute by supplying it with a null. In this instance, if the Toggletip size value was small, we can just omit the style attribute, as the default CSS values are for small. The next method, focus left control, is the method that JavaScript will call when focus has left our Toggletip. For this mechanism to work, you need to use either the JS invocable attribute or for the public method to be static. All we do in this method is to set our private field to false to have the Toggletip closed now the focus has left our component. Lost focus will occur when the end user tabs out of the Toggletip or clicks on something outside of the Toggletip. We then request a render via invoking status changed so Blazor can update the DOM. Finally, the disposeAsync method called by Blazor during component disposal. Here we just dispose of our .NET object reference and have JavaScript unregister the handlers before disposing of our reference to the JavaScript module. And with that, we are done. One final word. After reviewing the CSS, I noticed a couple of missing properties which I have since added, and I would always suggest that you look at the GitHub repository for any changes. As always, please feel free to leave good or bad comments, and I will do my best to answer any questions raised. All of the appropriate links are within the video description. Thanks for watching. Until next time, bye for now.